Hello, Precalculus. We are back here with the 10-1 day one notes. Super exciting. I forgot to mention this in the last two videos. Don't forget to check out the Google Sheet so you can see the pacing for this chapter and what we're going to be doing each and every day. It's going to be awesome. So stay with us. All right, so we talked in the first video about an explicit formula, explicit rule, explicit sequence, call it whatever you want to. You should love the explicit formulas because they don't require too much work. So if we want the fourth term, it means that 4 is the input. So a sub 4, 2 times 4 squared minus 3. If you want to jump straight to your calculator, you can. If you want to do more work by hand, then that's fine too. I wouldn't need to see lots of work on this one. You can just go straight to the calculator and get the answer. So all I care about is, can you set it up with step number 1, and then can you get the right answer of 29. You don't need to do the middle steps there if you don't want to. So there we go. Super fast, super easy. But video 1, we also talked about the recursive sequence, the recursive rule, recursive formula. Quick reminder, there's two parts. There is the first term, and then there's the rule that helps you get each additional term. So we want the fourth term, but I can't do that until I know the third term, and I can't do that until I know the second term, and I can't do that until I start with the first term. So there we go. Let's do it. A sub 1 equals 3. There's the easy part. Now I'm going to jump to the blue to match my other underline there. So now I want to get the second term. How do I do it? It says take 2 times the term that came before it. So what came before a sub 2? A sub 1 plus 5. So that's going to be 2 times some number plus 5. I'm going to act really cool here and go back to the red because that term is the 3. So whatever I had previously, that's my term, my input there. So 6 plus 5 is 11. So the second term is 11. Now I want to get the third term. So I'm going to go 2 times the previous term, which is a sub 2, plus 5. So 2 times some input plus 5. And my 11 was written in blue, so I'm going to put that input right there. And that's 22 plus 5, 27. Let's go Glenbard Green, go west. And so that's 2 times the previous term, which was the third term, plus 5. So 2 times some input plus 5. And I'm going to go purple because the input was 27. And so now that gives us 54 plus 5 is 59. And there is the final answer for that one. So that's recursive. I might make a separate video to show you a cool calculator trick that you can use for some recursive problems, not all of them, but it might be something you like. So stay tuned. I will try to get that done. All right. What I like about number 5 is trying to put everything together, asking you for 2 different rules, both explicit and recursive. I'm actually going to suggest maybe let's do the recursive rule first. No matter which rule you want to do first, though, it kind of goes back to our video number 2, where we want to look for a pattern. So my numerator is not changing. When I look at my denominator only, I can say times 5, times 5, times 5. And that's correct. Now, but when I'm looking at actually getting from one fraction to the next, I'm not multiplying by 5. I'm actually multiplying by 1/5. So that's how I'm getting from one term to the next, is multiply by 1/5. So we will do the recursive first because it's less work. So recursive, though, does have 2 parts. It says, hey, what's the first term? That's too easy. 2/5, no big deal. And then now it says, make the rule to get the next term. So I'm going to go back to my green where I wrote multiply by 1/5. So it's 1/5 times the previous term. And that a sub n minus 1 is our notation for previous term. So that's probably the best way to do the recursive rule. Let's take a look at explicit. Okay, I didn't use that blue. Explicit. There we go. So one thing to keep in mind on some of our explicit rules, I guess I can go purple. So that's where you just write a sub n equals, and we're going to come up with some formula. And this one is really cool because there's more than one correct answer. So that's nice having that flexibility. First thing you'll notice is my numerator is not changing on any of those problems. So that's kind of a done deal. Keep that guy as a 2. Now to get my denominator, I'm going to go ahead and grab a color here. So keep in mind that these terms here are the outputs, and my inputs are 1 for first term, 2 for second term, 3 for third term, and 4 for fourth term. And so now I'm going to look for a pattern. I'm going to zoom in again if that's okay. So this is actually 5 to the first, 5 to the second, 5 to the third, 5 to the fourth. So now I can see that those numbers match. Sometimes you end up having to increase by 1 or decrease by 1 or something like that, but I wanted to make this one super friendly for you. And so you can see how those are the same. So now our denominator, I'll make it match the pink, that's fine, is 5 to the nth power. So if I input 1, I get the first term, input 2, I get the second term, and that works out perfectly. Turns out there's a different answer that you'll probably do once we get to lesson 10.3. But for now, this is a perfect rule, so we're good to go. All right, last problem for this video is back to converging and diverging. So I am going to suggest looking at the table is probably your best option. Sometimes the graph can help, sometimes the graph won't show up. And so table is usually nice. And what we want to look at are all the values as when we're going to look as the x value gets bigger and bigger and bigger. Is it getting closer to the same number? Or is it getting closer to positive infinity or negative infinity? Or is it alternating between really big and really small numbers? Another possibility, though, that does work sometimes is if you think about limits, I could just take some really big number like 10,000 and input that for the n value. But sometimes that number 10,000 is even too big, and your calculator is going to say error overflow. Well, that means the number is too big and it's getting close to infinity, or negative infinity, which means diverging. So that's another option. So if you want to pause the video right now and try it with your calculator, obviously we're going to use x in place of the n, and that's no big deal. You can look at your table that way, or you could go to the home screen on your calculator and just type in some big numbers. So if you want to pause the video and try those, that's fine. I'm going to run through the answers, and if you need any extra explanation, please reach out and we will help you. So this one should converge. The numbers get closer and closer and closer to 0. The next one is going to diverge. Again, normally I'd make some divergent joke about the dauntless and the erudite, but I'm not going to do that. We're just going to keep doing math and having fun. And letter C is also going to converge. All right, so we'll stop this video for now and join me for another 1 or 2 videos on this lesson. Thanks for listening. Adios.